All right, in this video, we're going to go over all the steps that are necessary to perform these matrix calculations in a TI-83 or above calculator. All the problems we're going to be going through are from the Unit 2 review. So the first problem we're going to do is number 4, which is multiplying a matrix by a scalar. So we've got -4 times, and then to open up a matrix, you're going to click alpha zoom, indicate the number of rows and columns for your matrix, and then hit enter. Then enter the elements of the matrix, -3. Make sure that you're clicking the negative sign and not the subtraction. So -3, -2, 5, 5, 3, and -4. Cursor all the way over to the right, hit enter, and that is our actual answer that we should have gotten. All right. Next, we're going to do addition and multiplication in the same problem. We're going to do number 7 on the unit review. All right, so we start with that 2 by 2 matrix. So we click alpha zoom. All these matrices are 2 by 2s, so we want to change the dimensions to 2 rows, 2 columns. And then enter that first matrix, which is -6, -3, -2, and -1. And then we're going to press plus. Into the next matrix, alpha zoom. It's also a 2 by 2 matrix. The elements for that matrix is 0, 0, 0, 3. And then multiplication sign. And then alpha zoom again to pull up another matrix. The last matrix is also a 2 by 2. The elements of that matrix is -3, 0, -4, and 3. Cursor to the right, hit enter, and that gives us our the matrix, which is our answer. All right, we're going to go on now to determinants. So we're going to do 21 on that same Unit 2 review. 21 is a 3 by 3 matrix. So we press alpha, zoom, change the dimensions to 3 by 3, 3 rows, 3 columns. And then enter the elements of the matrix. Actually, let's clear that because we're finding the determinant. So the first thing we want to enter is the determinant. So we're going to press second and then the inverse button. That'll send us to this screen. Cursor over to the right so that math is highlighted, and that first option there is determinant. So we're going to press 1 for the determinant, and then we're going to pull up the matrix alpha zoom. It's a 3 by 3 matrix, and we enter the elements of that matrix: -1, 2, 2, 4, -2, -3, -1, 2, and 0. Cursor to the right, hit enter, and the value of that determinant is 12. All right, next thing we're going to do is find the inverse of a matrix. So we're going to do number 29 on that review. So we're going to start by entering the matrix, alpha, zoom. For 29, that's a 2 by 2 matrix, so we need to change the dimensions. All right, then enter the elements of the matrix. We have 3, -2, -8, and 7. All right, so now to get the inverse of that matrix, we're going to press the inverse button right here. Press the inverse button, and remember the power of -1 means the inverse. So we just hit enter, and we have the all the values, the elements of that inverse matrix. If you want you should be able to, on your calculator, there should be an option right here on your calculator that allows you to see the answers as a fraction. If you need the answers as a fraction, you just click mode, and then for that answers row, instead of clicking auto, just click on fractions. You should have a fractions option on your screen. There's not one on this. There's not one on this. TI portal that I'm using on the computer, but you should have one on your computer. All right, so that's how you find the inverse of a matrix. Next is going to be the system, a 3x3 system. A 2x2 system would be a similar process. So we're going to go over, this is number 43. It's number 43 on the review. So this is the 3x3 system. Notice in that second equation, I put in that placeholder for the y term because there's no y term in that second equation. All right, now you guys, that matrix, that 3x3 system, if I was going to use matrices to represent that 3x3 system, this is what I would have. All right, 4, -3, -1. And then if I multiply each one of those rows of that 3x3 by the 3x1 matrix XYZ, I will get that resulting the 3x3 system that I started off with on the left. Now, if I want to solve for XYZ, which is what I'm looking for the solution, I would divide both sides by that 3x3 matrix, which dividing both sides by the 3x3 is the same thing as taking the inverse of that 3x3 matrix. All right, so to get just XYZ matrix all by itself, I would just take the inverse of the 3x3 matrix and multiply it by the constant matrix. All right, so that's what we're going to be plugging into the calculator. All right, so let's clear this all out. Let's start with the 3x3 matrix. So alpha, zoom, change the dimensions to a 3x3. Enter the elements. So we have 4, -3, -1, -5, 0, 1, oops, 1, and then the last row is -1, -5, 2. All right, and then the inverse, to get the inverse of that again, press the X inverse button right here. And we're going to multiply that by the constant matrix, which is a 3x1 matrix. So alpha, zoom, change the number of columns. There's only one column. And 13, -21, and -2. All right, cursor to the right, hit enter, and that is our solution. The solution, the x coordinate is 5, y coordinate is 1, the z coordinate is 4. All right, so that does it for the matrices. Last thing we're going to do on the calculator is the the systems of linear inequalities. All right, so let's just clear this. We're going to press the y equals button. We're just going to graph each one of these lines. So we're going to be doing number 47 on that review. We've got the first inequality is 3x plus y is less than 1. So to isolate the y, we would subtract 3x from both sides. So we would have y is less than 3x plus 1. And because we have a less than symbol, we want a cursor over here to the far left, and we're going to tell the calculator to shade, we're going to tell the calculator to shade below the line, because all right, so you want this indicator to shade below that line since we have a less than symbol. And then for the next inequality, we'll have y is greater than negative 3x minus 3. So I want to change this to shade above that line. So that is what the indicator we want to shade above that line. Then enter the rest of that inequality, which is negative 3x minus 3. Negative 3x minus 3. We actually need to fix that top inequality. The top inequality should be y is less than negative 3x plus 1. All right, so graph it, and where those two spaces overlap, that is actually our solution. If we click zoom 9, it should kind of narrow that space, give us that. Let's take a look at the equations. All right, we got y is less than, okay, so, all right, both of these lines have the same slope, so they're parallel. So whenever we graph them, the space where the two shadings overlap is this space right here in the middle. All right.